of that expression. So Bob does the same thing, but he does it with B. So at this point in the story, Alice has A, and she has g to the b mod p, aka TB, whatever that number actually is. And Bob, meanwhile, has B and what Alice sent him. Well, now, thanks to the ability to multiply exponents, you can actually now compute the same value at both sides. So Alice, upon receipt of g to the b mod p, she takes that whole value and just raises it to the power of A, her number, and then does a modulo p again. And thanks to nice mathematical properties, what she really gets then is g to the a times b, or equivalently g to the b times a mod p. And Bob, meanwhile, gets the exact same results. So it's done in the opposite order, but the product ultimately is the same of those exponents. So at this point in the story, Alice has a secret number A that she did not send across the wire. Bob has a secret number B that he did not send across the wire, but both of them magically have this big number, g to the a times b mod p. So what then is going to be a number that they can then use securely? Well, they have effectively come up with a shared secret. So much more sophisticated than a Caesar cipher number of 13. They now have a nice, big, seemingly random number to use that never went across the wire. So this is, in a nutshell, how you can use public key crypto to exchange information securely. They now have a shared secret. RSA is a little more sophisticated, but again, if you're liking this kind of crypto stuff, do shop at some point one of the higher level CS classes. All right, so now let's come back to a story that we hinted at earlier, and some of you might have seen, so we'll do this one somewhat quickly, but it's nonetheless always fun. So suppose you want to log into a website, and you're not supposed to. One of the fun things to do when you're bored is to try to see if the website breaks if you type in some bogus characters. In fact, if you want to try to exploit a website, what are some good characters to type into the username and or password fields of that website? So null characters. So you can actually somehow copy and paste null characters, which you can get from like a sophisticated text editor, for instance. So you can just paste those in, which normally you couldn't type easily. Even simpler. What else is juicy? Parentheses, single quotes, semicolons, double quotes. Generally, quotes are a pretty good bet, because if the website is using SQL, they probably do have some quoted strings in their queries. And if they didn't have the foresight to actually scrub user input, you might actually trigger an error. And this is where adversaries get their advantage. I don't need to compromise this site in the first 5 minutes, but as soon as I get it to crash or yield some kind of server-side error message, that means someone screwed up. And then I can focus my attention and my interests and my spare time all the more deliberately on this site and figure out, well, what sequence of bogus characters should I type in to do more than just crash the server, but rather to somehow take it over or steal some data. So in this case, here's a very common example. And some of you, if you went to Hack Night recently or last year, you've seen this example before. This looks completely ridiculous. And I actually artificially removed the bullets that would generally appear in the password field. But suppose a user does type in single quote, space, or space, quote unquote, 1 equals quote 1, but no close quote. So notice the awkward asymmetry here. I start with a single quote, but I don't end with a single quote. And that's because, on a hunch, I feel like whoever implemented this website is probably doing a query like this. And this is one of the more simple approaches you can use in PHP. The goal here is to generate a SQL string. sprintf is like printf, but it returns a string rather than printing it to the screen. So select user ID from users, where username equals quote unquote %s, and password equals quote unquote %s. So that feels reasonable. But if what I then plug into those placeholders is literally what the user submitted, very bad. Right? So if I have not scrubbed the user's input, they could have typed anything, including that cryptic sequence of ones and equal signs and single quotes. And if you think about what I did type, I started a single quote, but I didn't end with a single quote. So whatever I typed in is going to end up where this %s is. And I didn't even type in a username. So if I now do that substitution, what does that query become? Well, it becomes this. And what does this where clause evaluate to? It's a sort of a vacuous truth. It's always going to evaluate to true. So what am I going to get back? I'm going to get back a whole bunch of UIDs. In fact, all of the user IDs. And if the next lines of code in the program are only checking for the presence of one or more user IDs or no user ID to determine whether the user exists, well, odds are I've just maliciously logged in to the poor guy whose UID just happened to be first in the results set, the very first person to log in. And maybe that person doesn't even use their account anymore, so now I'm into a fairly dormant account. So what's the solution here? Well, clearly the fact that I was able to finish the developer's sentence, so to speak, with those SQL queries was not the best decision. So it's a ridiculous function in PHP, but this is one way you can do it. MySQL real escape string, which pretty much puts backslashes behind any potentially dangerous characters, among them the single quotes. So what that query would look like if we escaped it is something like this, which is actually hard to parse visually, but it's actually now safe. All I did was escape the single quotes that the user actually typed into that password field. So it's this simple, but clearly people make this mistake. And in fact, I was just reading today, and I didn't look too closely at the article, but this outbreak of the Mac worm that everyone's been freaking out over seems to have been popularized in part by compromised WordPress blogs. And it always seems to be WordPress or Joomla or these very popular CMSs and such that infect the world with everything because they use stupid functions like eval. They don't have escaping going on all that often, but it's so easy to forget these things. So indeed, one of the things we talked about early in the semester, PDO, one of its most compelling characteristics is not just the abstraction you get between using MySQL or Oracle or the like. It also does all of this stuff for you. And that's huge, to just distrust yourself. So getting into the habit of not using raw PHP functions like this, but actually using a library where you can assume or at least trust that someone else has given this more thought than you might is probably your best defense. And to stop thinking about escaping, but punt to a library that's going to do it for you and do it correctly. Super easy to do. So lastly, and Yella pointed one of these out before. So there's actually two attacks when it comes to web security that are actually a little non-obvious, but you hear these buzzwords tossed around a lot, perhaps because so many people are in fact vulnerable to them. So cross-site request forgery, sometimes written with an X instead of a C. So here's the scenario. You log into something like eTrade.com. You then go to some other bad guy's website, but that bad guy has a link back to eTrade.com, and it uses a GET request to essentially trick you into this case into like buying a share of a stock. So in other words, you go to eTrade.com, you log in, therefore you have a session cookie with them. And just because you leave the website doesn't mean that session cookie expires. In fact, it might not expire for an hour or a week or a year. So you're still logged into eTrade even though you're not physically seeing that page. So if you somehow go to this guy's website and click on that link, you've just been tricked potentially into buying a stock on the other website. And you don't even have to click a link, right? He could just do an HTTP redirect on you. It could be in a form submission. He could have even more cleverly this tag embedded, for instance, in any of these, which is super clever. Things that you wouldn't even notice or see, right? All of those would trigger an HTTP GET request to some other website just to see if that website is vulnerable. So how do you defend against this attack? And indeed, those of you who took 50 and did CS50 Finance, odds are you didn't really defend against this attack, albeit with your fake eTrade-like site. So how do you defend against this attack, which seems so relatively easy to wage against your users? Yeah?
Can you generate a random key every time you load a form on your own site so you know that the request is from your own website, not from somebody else?
Good. OK, so you can kind of have some kind of seed value, some kind of hash value that has to be resubmitted with the stock purchase that a bad guy's random website would not know because it's constantly changing. But if you actually did commit this buy on the real eTrade.com, that would be a hidden form field that comes with it. So a kind of a token, a temporary token. So that could be one defense. Now, of course, the bad guy could really be malicious and somehow sniff that cookie. But let's assume our adversary is not sniffing all of our traffic. What else can you do? Yeah, Kevin.
Could you make people like re-log in if they want to buy this stuff, or like when they get to that link, have them read?
Good. Yeah, so I'm kind of being unfair to eTrade. Odds are they don't have like one-click stock purchases features, right? Where you just send a GET request and you buy the stock. Odds are they'll prompt you to at least confirm, or even more securely, prompt you to re-log in. In fact, if any of you shop on Amazon.com, it's a little annoying, but they do exactly that. And every time you add stuff to your cart, you then check out, and then they prompt you for your password again, even if you just typed it in. And that raises the bar. What else could you do here to defend this? There's kind of an obvious one, even though it's not perfect. Yeah?
You could check the refer, but that's not very secure.
OK, good. So you can check the HTTP header, the HTTP referrer header. But indeed, that can be very easily spoofed. It can be scrubbed by browser privacy settings or special proxy software. So good as a heuristic, but not as something to rely on. Good. So if the whole problem is that gets are just so damn easy for other people to construct, well, let's just use posts instead. Now, of course, that would fix, in this case, all of these attacks. All three of these links would now no longer work if we only supported post. But anyone who knows a little bit of JavaScript can actually trick you into submitting something via post and can even redirect you via post by having a little JavaScript event handler that says as soon as you're on bad.guy.com, do form.submit, open paren, close paren in JavaScript, and bam, you've just submitted a form via post elsewhere. So it does raise the bar and makes these kinds of attacks harder, but doesn't solve it perfectly. But in conjunction, pretty good things. But really, again, I would propose that the takeaway here is that if you never even